let me just say thanks to everybody for joining us today. This is one of our coffee breaks. Here, let me turn that off real quick so you can see me if that is helpful or not. But anyways, thanks again for joining us, everybody. I'm going to mute everybody at this point. Brian, again, unmute yourself real quick. And if you do have any questions, just go ahead and type those into the chat. I'll be reviewing those, and towards the end of the conversation, we will actually bring those up. Of course, you're welcome to stay after the 15-minute phone call if you've got any specific questions that you've got, you want to go over something, or we can schedule another time to meet. Just again, to remind everybody so that they know we're recording this session that we'll have available to you if you would like to view it at an alternate time, have other associates that might be interested in the content. Just be aware of that. So again, I welcome you to this. We're going to try and do this, let's say, bi-weekly presentations, just to give you a feel for what's going on there, help you understand some of the things that we've seen, especially in the changing times where we live with COVID and the responses to that, and then to talk about other products. So hopefully look out for future invites from us for titles and recordings such as this. And as all you know, my name is Jeff Grant. I'm with Long Building Environments, been here nearly 20 years. And before that, some other organizations from engineering to sales as well. And of course, we represent everything soup to nuts in heating, ventilation, air conditioning. And with me today, and I'm going to share my screen right now so you can see a little bit about him, is Brian Abel. He is with AAF. And just to let you guys know, AAF is changed maybe from what you may have known in the past. They are more than just the AAF. Flanders was actually bought out by AAF. So just so that you're aware, those are kind of synonymous at this point, and you can certainly change your specifications if you'd like to, in order to represent that. Usually a lot of times we see AAF/Flanders. So Brian has been around for quite a bit of time. He's given these presentations in the past. This is a condensed version of something that took an hour before, so we'll cover just the highlights, and we could certainly get into more specifics should you need it, especially for projects in particular. So anyways, he's been basically with in HVAC for 27 years, really a filter specialist, and that's what we'll be covering today. Give me just a minute here, as I'm going to try and get back to the lobby if I can somehow, in order to admit some of these other people. I was trying to do that as I was talking, but I'm not as good at the multitasking as I thought. Okay, I think I'm going to have to stop sharing for a second.
I think I just admitted them, Jeff.
Okay, appreciate it. I'm going to mute all again for the short term, and we'll go from there. All right, so I'm going to share my screen once again. And the one thing I'm going to start with is, a lot of this has been brought to the forefront because of coronavirus, especially, and I've sent in the invite some of the ASHRAE guidelines, at least a link to those that certainly you can research on your own. But a key part of that is increased filtration, and MERV 13 is really a key target number that ASHRAE addresses that can certainly help where we are right now. But the conversation that we have is bigger than just the COVID experience that we're going through right now. It goes for a lot of other MERV ratings that you might have on other projects, and how do you actually get true MERV ratings? One of the other reasons is the ongoing research that we see coming out to the public, like this right here talks about dust as a potential carrier and spread. This was just, I think, published in the past few days. But it talks, again here, the airborne transmission of the coronavirus has been thought to be possible through close human contact. But new research shows coronavirus spread can be extended and facilitated by fine dust particles in the air. So some may believe that we get, through the return air path, the chance of having virus spread to other areas. Some dispute that claim. But one of the things is what we find is a more filtered, a cleaner environment may have a reduction in transmission for coronavirus. So there's another reason beyond just what we want to have as our standard filtration to maybe pay attention to this particular topic and why it is forefront. So Brian, I'll let you go from here, and I'll get to the next slide to talk about this particular topic.
Okay, thank you, Jeff. So I've been with the company 27 years. I have worked my way through the sales organization, from sales rep all the way up to branch and regional manager. I've helped develop a lot of our systems, like our total cost of ownership diagnostic tool, and a new generation of sensors called Sensor 360. What you're seeing on this screen is a comparison of filter medias. So we've got two synthetic medias in here. The green and the red are synthetics, and we have two glass medias, which are mechanical filtration, in the blue and the yellow. This was a 6.5-month study that was done at Texas Instruments by their engineers. The test ducts were provided by Canville. And what I want you to notice in this study, the green was a MERV 15 95% product. All the other products on here are 85%. So what you're seeing on here is a significant drop off in performance, especially on that green one, but the green and red are synthetics. They fell off in performance. They did not improve for catching these really small particles that are affecting our health as they loaded with dirt. So the fine particles, the 0.3 to 1 micron, which your COVID and so on is going to be on a 0.5 micron and bigger moisture droplet or particle. The ability of these synthetics to catch those fine particles, they're falling off, and that's what we're seeing here in this diagram. In fact, I have pulled many filters over the years, some of these synthetic filters, and I've sent them in for testing after they've been in the systems for a number of months. And we'll show you that here on some of the future slides, the exact performance drop that we've seen on these synthetics. So we are recommending mechanical efficiency filters to control COVID. And if you're gonna use mechanical filters, we also need to look at the thickness of the filter tracks that are being specified in new units. You guys have the ability now to do something about it and make sure we have, when you design a system, you have the ability to make sure that we have room to put in mechanical filtration. And go ahead, Jeff, switch to the next slide. So this is one filter I pulled out. This actually was in a college. It had been in the system for 4 months. It was a synthetic. These are inexpensive synthetic filters. They're sold to mostly contractors, but you have other people that buy them too. So there's a lot less media in them. They use a synthetic media. All these synthetics, almost all of them have static charges on them. Some have more of a static charge than others. This was in the system for 4 months. We pulled it out. We did an initial efficiency test. This filter was supposed to be MERV 13. After 4 months, it tested MERV 10 with an initial efficiency test. And Jeff, you can go ahead and switch to the next one. This filter had been in the system in a hospital for a full year. It was supposed to be a 95% MERV 15 product. After a full year in the system, this was MERV 12. We sent it in, did an initial efficiency test on it. It had been in the system for 12 months. So MERV 12, 60, 65% filter. So this type of product is going to let a lot more of the really fine contaminant through it, including the particles that we're trying to control when we're looking at airborne bioaerosols. And for example, COVID is a good example. Jeff, okay. Good performance versus poor performance medias. The best performance medias, 95% of all our top performance medias are all glass. They're all mechanical filtration. We've got an example of some of those different filters. These are MERV 13 or higher. The only synthetic, well, we've got two synthetics actually that don't fall below a MERV 13. DryPack NX is a special hybrid synthetic. It's very rare to get these hybrid synthetics that are not falling in performance. That product has absolutely no performance drop, and it's got an extended layer of high efficiency media on the back of it. But 95% of your synthetics, or 99% on the market, are actually falling in performance, and that is true of all your 2-inch pleats. If you actually have a 2-inch product that is not falling, you're going to have a very high resistance on it, and it will be tested at really low airflows to make it where it doesn't look so bad, but it would block your flow if you put them in. Jeff, you can go ahead and move to the next one. So ASHRAE came out with Appendix J when they developed it, and they warned people up front that your average synthetic is going to fall 2 to 3 MERV ratings. We found even greater drop than that in some of the pleated medias. So when we're starting to look at health Everything is switching over to life safety now with COVID. So in the past, it wasn't. Life safety, we're very concerned with how well these filters are catching a 0.5 micron and bigger. 0.5 is your moisture droplets, your bioaerosols that carry these viruses. If they're piggybacking on some of the dust, it's going to be 0.5 and bigger too. So we're looking at the performance on that. We're recommending mechanical filtration. If you're going to allow a synthetic in there where you've got newer units and you can do something besides 2-inch filters, then you can start to specify mechanical efficiency. You can't do that if you only have a 2-inch filter track. So one of the things that one of the new webinars that we're doing is called Design Guides. Design Guides is going to get into these thicker filter tracks. What are we recommending in your system? How does it affect your customers? Total cost of ownership. Do they have the ability in the future to upgrade to something that'll do a good job on them? We are recommending that when synthetics are allowed, if you're looking for minimum MERV 13, they need to be tested to Appendix J for these higher end synthetics. MERV 13 or higher that is starting to deal with your facility's health or with the end user's health need to be, if it's synthetic, it needs to be tested to Appendix J. Appendix J is going to give you an idea if that product is falling off and what kind of minimum performance you can expect from it. So go ahead, Jeff, to the next slide. This is a picture of one of these design guides. We can't bring it up and show you a smaller close-up of it, but this compares, it's looking at different thicknesses of filter tracks, depending on what is specified in your new systems, 2-inch, 4-inch, 6-inch, 12-inch, or 22-inch, where we have room to put different types of product. One of the main things you're going to see with these design guides, where you're recommending for single stage units that you put in a minimum of a 4-inch filter track. That way we have room to put mechanical filtration in. So we have 2-inch filters in MERV 13, MERV 14 right now. They're all synthetic. You can expect all of these synthetic products to fall off in performance. Again, if we're going to actually put in a mechanical filter, we need tracks 4 inches or thicker. Basically, when you give a track you could do a header track that just has space behind it, but the deeper the track, the lower your customer's overall cost is going to be, the longer the product's going to last. So they're going to have reduced PMs, and the more you have an ability to put in better performance products. For COVID, they're actually recommending HEPAs to actually catch 100% of it. And that's assuming we have a tight seal and no leaks. A MERV 16 would catch about 98% of it. A MERV 13 mechanical filter will catch about 60%. We bump that up, that's of a 0.5 micron, that's your bioaerosols. MERV 14, which is used in your hospitals, will catch 73% or higher of these 0.5 micron particles. If you bump those up to MERV 15, which has a very little resistance difference between 14 and 15, but the mechanical MERV 15, we're up to 86 to 90% capture ratio. So here on the design guides, we've got a comparison. We're looking at that 2-inch track, your 4-inch track, your 6-inch track. We've got a comparison of the different filters we offer. Right here on this comparison, we're looking at the recommended PM, the change point on these filters. How long should you leave them in? We're looking at their estimated energy costs, and that's at 10 cents a kilowatt with a flat comparison across the board, and the total cost of ownership. What is the cost for the product itself, the labor to change it, the energy to use it? All that is involved in the total cost of ownership. So all of our filters are rated on these new design guides, and you can do an instant comparison depending on what you want to specify. The design guides will also offer a quick breakdown of the different equipment, the different housings that will hold these filters, so you can specify them very quickly. What is the depth of this housing if I use it? If I have cottonwood out there, do I need some type of screen on it? What is the part number, the diffuser screen that we should be adding to these systems? So again, this is one of the new webinars on design guides, and it will give you an instant comparison and make it easier to specify AAF Landers filtration.
Well, thanks again, Brian. At this time, we don't have any typed in questions, but one of the questions I'm often asked is, how do you make a synthetic meet the MERV 13, and why does it change its MERV rating over time?
Okay. The MERV 13, again, all synthetics, or virtually all of them, are going to have some type of static charge. To make a mechanical synthetic, we're going to have a higher resistance in it. Like the Dry Pack NX, what we had to do with that product is actually use a double layer media, and we dramatically extended the surface area on the back to actually catch the small particles to get a mechanical synthetic behind it. So again, 99% of your synthetics are going to have some type of static charge on them, whether we put a static charge, an extra static charge, or not. The lower pressure drop you see on a synthetic, usually the greater static charge has been put on the media to make it appear to have a very good performance at a low resistance. Yeah. That static charge starts to dissipate in 1 to 6 weeks. As we showed you in the graph, it will continue to fall for 6.5 months. And I pulled out product that is a year old, and the performance is not going up on these really fine particles until that filter is totally clogged. Now, the performance on the big particles, the big visible particles that we call arrestants, that will improve as the filter's clogged. But the ability to catch the really fine particles is not improving on those statically charged synthetics for a very long time until that product is very, very loaded with dirt.
Excellent. I guess at the end of the day, buyer beware. I mean, you might be tempted by a 1 or 2 inch synthetic filter that has 1/10 of an inch of pressure drop that's rated at MERV 13. But unless you change that out every 1 to 6 weeks, you're probably not going to get that MERV rating, which again is kind of the dirty little secret we see of the entire industry. A question came in from Jordan. Can you briefly explain the A designation on the MERV rating, like a MERV 13A versus just a MERV 13?
A means your filter was tested to Appendix J. Appendix J is trying to identify the drop off in these synthetics, and it loads the filter over it loads it with more of a dust that's going to give you a representation of the performance drop over the life of the product, or a better idea of the performance drop. So when you see an A on a filter, it is a synthetic, and that should be giving you an idea of what the bottom performance you can expect from it is. For example, we have a Vericel 2 Plus high capacity product. It's rated MERV 15, and then there's a /13A. That 13A tells you that MERV 15 synthetic is going to fall to a MERV 13 product. So again, on synthetics, MERV 13 or higher, you're going to need a thicker than a 2-inch track to get these products. They're going to be MERV 13 or higher in synthetics.
And an engineer would probably want to at least account for 1/4 of an inch, maybe 4/10 of an inch on a 4-inch glass fiber true MERV 13 type of filter. Is that right?
You've got your on 4-inch. Let's talk about. We have 2 different options. We have a glass fiber. Your pressure drop on that glass at full velocity, 500 feet per minute, is going to be up around a 0.7. We do have a MERV 15/13A synthetic that would meet the minimum. Its resistance is only about a 0.41, 0.42. So there is that is an option in a synthetic to get you a little lower resistance. When you start loading these filters with dust, usually the glass product is going to hold a lot more dust before it increases in resistance. So that's another thing you don't see. These cheap synthetics that have a very low resistance, many of them have not very good dust holding capacity. And the dust holding is the ability to last longer before the resistance is building up in the filter. So these cheap lower grade synthetics have a lot less dust holding. They're going to load much quicker, and they're going to fall off in performance. You're going to need that Appendix J or A rating after that MERV 13 rating or higher.
So I guess some of the takeaways then is that, first off, if we are getting a true MERV 13, expect higher filter pressure drops. There's no such thing as a free lunch there. So you can certainly accommodate that in your designs. And you may want to make a note not only in your specifications, but I would suggest on the schedules as well. If you do want this rate it as a MERV 13A. Don't just say MERV 13 and then have a note down there explaining that A rating is rated to Appendix J in the ASHRAE code. So those are some ways as a design engineer that you could enhance those designs.
And
well,
the
we're coming
would be for synthetics, not the glass mechanical filters. Most people aren't going to be testing the mechanicals to Appendix J. It's very expensive, and the products are not falling in performance. The glass medias.
Gotcha.
So that's if synthetic is allowed, require a rating on that 13 or higher.
Very good.
Okay.
Well, we're coming to the end of our time. If anybody wants to stick around for an additional conversation with Brian, we certainly have the time. I'm going to stop recording at this point, and I want to thank everyone again for your attendance. And please call me, call along. Let's discuss your next filter project. And thanks again.